Unit 2A test review question number 10. Assume the graph above is the result of three different buoys whose height above or below steady water, not steed water, not sure what that is being monitored in the Pacific Ocean over 13 days. X equals 0 is day 0 times 0. Number 1 is our red graph, number 2 our blue, and number 3 is our green graph. It says, during the first 2 days in which 6-hour snapshot does buoy number 1 appear to have the highest height. So I'm going to go to my graph and I'm going to say, okay, here is day 0 and here is day 2. And it asks in the first 2 days, when does our red graph, that's buoy 1, have the highest height? And I see that our highest height is right here. The first thing I need to do is figure out if this is day 1 right here, how many of each of these other tick marks are part of day 1. So I see that there are 4 different intervals between 0 and 1. So I know that one day has 24 hours. I'm going to divide by 4 and I get 6 hours. Now when I look at the highest height, I see that it is at the 3rd tick mark on my graph. So I'm going to multiply 6 times 3 and I get 18 hours. So between the first 2 days, buoy 1 is at its highest point at 18 hours. Our next question asks from day 3 to day 7. So if I look at day 3 to day 7, it is asking me when does buoy number 2, which is our blue buoy, have a height that is less than our buoy number 3 or our green buoy. So I look here and I say, well, here is 3 and our blue is definitely less than our green, which is way up there. So I'm going to, on my interval, I'm going to say that this is going to start at 3. Our blue is definitely lower, so it can be an inclusive 3, comma. But when I look at our day 7, I see that our green graph starts to go below our blue graph right here. And that's really at about 6.25 days, or 6 days and 6 hours. So I am going to go to 6.25. Or you could have written 6 hours and 6 days, but 6.25 is good. I'm going to do a parenthesis, and at that point our blue graph actually starts getting greater than our green graph. So I can't include this point because this is where they're equal, so I will do a parenthesis. Our final question on this one, and our last one, D, I'm going to do on another page because it's going to require a little bit more space. So I'm going to answer this one next. What is the average change in height from day 6 at 6 hours? So this is actually this orange point that I had circled before, all the way to day 9 at 12 hours, which is right here. And what I see is it's asking me about our red graph, and I'm going to go ahead and we're going to just outline our red graph right here. It's asking me for this, and I actually see that this completes one full cycle of our sine wave. So if I look at the top, the average change in height would actually be 0 because it is equal amounts above the x-axis it is below. So if I take the average height, they would cancel each other out and our average height would be 0. Okay, now the next part of our question asks us to write the equation for buoy number 1 in the form of a sine. And when again, my buoy number 1 is my red, and so I see that it starts at 0, 0, so I'm going to use this one to do our graph so that I don't have to worry about any horizontal or vertical transformations. And then I just have to sort of guesstimate what this point is, and I see that it is between a 3 and it's between, that point is between a 3 and a 3.25. So I know that it's at really a 3.125, which is probably about 3 hours and 3 days. 3 days and 3 hours, excuse me. All right, so when I write the sine wave, I would write y is equal to, this is my period, and so if I think of it as this, 3 1/8, I'm going to change this decimal into a fraction, and then I'm going to change this into 25 over 8. Again, I did 8 times 3, and then added the 1, so 25 over 8. That is my period, and I know that my period is equal to this 2 pi over b. So if I cross multiply here, I'm going to get 25b is equal to 16 pi. I'm going to divide both sides by 25, and I would get that my b is equal to 16 pi over 25. So when I write out my equation, I know that my A is 1 because the amplitude right here is a 1. And so I don't have to worry about my A, and so I'll just write sine, and it's going to be 16 pi over 25 times x, and that would be my equation that I'm going to use to predict the height of buoy number 1 on day 5. Now, again, it doesn't have an H or K because I started here at 0, 0, and it doesn't have a vertical or horizontal shift there. All right, let's go look at the next part of our question. Okay, Unit 2A, test review number 10. To predict the height of buoy number 1 on 5 days, I did several things. I'm going to go through these. Here's my calculator pictures of what I did. I went to my calculator and I went to y equal, and I input our equation, the sine of 16 pi over divided by 25x. I went ahead and put that into y1. And then I went to our window and I did an x max between 0 and 10 and a y min and y max between -2 and 2 so that I could see our full curve. And then I hit graph. You're going to have to pretend this graph is in red as it is above. And this would be our buoy number 1, our graph of that. And then I simply went to the table. In our table, I'm going to go ahead and expand this. I look at R5, and I see that it is right here, that the height on day 5, our y value, is equal to a -0.588. And that would be my answer for the buoy height on day 5.